Yeah, GM. Welcome back to the Anchor Founder. How's everything? How has it been so far? How's everyone doing? It's Friday now. Today's Friday, so let's see. Let's have some love in the chat. Where you joining it from? How's the week been? How has the Anchor Founder been to you? What do you think we should improve? What other topics would you like to cover? We'll be doing some other non-technical topics soon, but more of technical stuff, right? But we'll be doing some non-technical founder related topics soon. But for now, let's just keep jamming. Let's keep eating those Anchor programs, Nokia programs, Solana programs, everything is Solana programs, right? So today, what we'll be talking about is VRF, verifiable randomness, and ephemeral rollup with Magicblock, then a sign off on token extension. So we'll be doing it backwards. Start from the sign off on token extensions, then we move on from there. So sign off on token extensions. So let's do. We have a couple of people that are interested to be backstage, but they are not online right away. So let's just do. Let's keep busy before they come aboard, right? Yeah, like yeah. Let me do get back here. Yeah, in a minute. In a minute. In a minute. Trying to share my screen. Am I live? I should be live. How many platforms am I on at the moment? Okay, this should be here. This goes here, and uh-huh. Today, final sign off. I hope everybody, a lot of people, were able to code along and gain clarity on how transfer books work. Yo, Emas, GM Emas. So I hope a lot of people were able to code along and get clarity about transfer hooks, right? This is the Anchor founder, and I'm trying to share my screen. All the story I'm saying is just to keep you occupied while I share my screen, right? It's crazy, bro. Okay. And sharing right now. Yep, my screen is live. Beg! Yo, you guys will not believe who just stepped into the stream. Beg, if you don't know, Beg is my instructor, one of my instructors over at Solana Turbine. So it's amazing to see the instructor showing love. Showing love, yeah, it just made my day. You know, was it last week or 2 days ago? Andre was on the call. I was like, bro, Andre is CTO at Solana Turbine. And yeah, we have Berg, we have Dave. Dave is also in the court. Amazing folks. Yeah. So today, let's just do a final sign off on token extensions before we move to VRF and ERs. I forgot I have to turn on my VPN to access Solana website every single time, bro. I'm in the United States of America right now, based on my VPN connected. Let me increase the fonts a bit. Mhm. Then, okay, like we said, so let me pull up Excalibur real quick. Excalibur, I have it here. Excalibur. I have a lot of drawings on my Excalibur. Not a lot, though, but just an infinite canvas. So how we started off with trying to solve a simple transfer hook, not simple, basically. We started off trying to solve a transfer hook problem, which this is just a vault, a token that only allows whitelisted users make transfers, right? If you're not whitelisted, you don't go through. Basically, that's what we started off with. Then that's what this is about. This looks like a a, a, a grade two student do this. It looks like a kid drew this, but yeah, you get the idea. So the next thing we went on to was an escrow, right? Escrow. It says escrow. I'm still trying to remember what it said. So went to escrow and we did. The reason why we touched the escrow was just to get familiar with light SVM, right? So the test, but for today we are using TypeScript for the TypeScript folks. Yeah. So we did escrow then. That the next call, I think the next two calls. The next topic we covered basically was escrow with light SVM, just getting familiar with light SVM while doing your test. And we had JK on the call then. Then the next one was this. This one is now a vault on top of the transfer hook, right? So this was the last thing we concluded. So this was the last thing we concluded. Then today is just about going over everything. Then moving on to VRF. And yeah, wait, I want to confirm if you guys can hear me because yesterday I was not audible till around 13 minutes into the video. That's crazy. 13 minutes, I was just rambling on myself, bro. It's crazy. So someone commented and said, there's no audio in this thing till that was people that watched the replay. So everybody that was on the call did not even say anything to I was like, let's just watch this guy keep going on and on and on and on. So let me know. Okay. Berg said I'm good. And so let's go on transfer hooks. The number of hooks, there are a lot of hooks from like I said, a hook is just a side effect that gets called when a transfer happens with the token. That's the possibility that token 2022 gives us, right? So a hook is the side effect that gets called. So there are different kind of side effects. This one is a transfer hook extension, right? A different kind of hooks. This one is a transfer hook extension. So what this does is it opens up all these possibilities. NFT royalties. Let's say I want to sell an NFT. I have an NFT marketplace, and I want to ensure there was actually this problem before SPL Metaplex Core. So this problem where some platforms do not honor the royalties, the addresses that are included in the royalties for NFT, right? But now with this solves all of that. No, initially everything we only had one major Solana token program, the SPL token, right? And it was all rainbow and sunshine until it was not because people needed more things, and to do those things, you needed to do other things. Why don't we just have it baked into one single thing, right? So that was why some people came up with Token 2022 proposal, and here we are now. So there are a lot of interfaces like let's see fallback instruction. Okay. This docs is particularly about transfer hook, right? Let me check if they're okay. Let's do this before then. So enforcing NFT royalties, blacklisting and whitelisting. We've played a lot around this, right? Implementing custom fees on token transfer. I think Emmanuel did this. Emmanuel did this. I would have loved to do this too. But we're moving on to other topics. I don't know if Emmanuel is on the call. If you'd like to come backstage and show us how he did this, he added this on top of his own transfer hook. So when he makes a transfer, apart from the fact that you are whitelisted to make the transfer, you get a custom fee. It's basically the same ideology, right? But extra work. So you make a transfer, then on your transfer hook, you transfer an amount in fees. You get some amount in fees, right? It might be on that same token, might be on a different token. Depends on how your structure is. So you might want to get fees in a different token. I want to get fees. It might be like I want to make a transfer of 10 USD, but for 10 USD, you have to pay me an extra fee of maybe two Shiba or two dogs with art, whatever token it is, or two Pepe. So you need to have most of the things are pretty pointless. Yeah. What Beck said. Then in his own opinion, most of the extensions are pretty pointless. Hooks is one of the most interesting ones with real use case. Like exactly. Because hooks cover this transfer hook covers everything. It just covers everything. You could literally do every other thing with this transfer hook, depending on how more code you want to write to. So you can create custom token transfer event, can track statistics over your token transfer. Let's say once it took a transfer happened, you want to log that information into a different program, a different PDA that keeps tracks of, or you want to call an oracle to update the state. Every form of side effect you can think about. It's yeah, it just now comes to how creative can you be to do these things, right? So that's basically it. And to achieve this development, yeah. So let's just go over it again. We've talked about it over like 2 weeks now. So let's go over it again. To achieve this, developers must build a program that implements the transfer hook interface and initialize a Mint account with the transfer hook extension enabled. Basically, that's just it. You have your okay. This for this first task here. For this first task, this one, the transfer hook was inside the token program. So it was like a program that had a Mint. Let me just show instead of saying GitHub, GitHub, with tests. I think this. Okay, this is yeah. Let me check this first. This was a challenge for week 2. This task, this challenge was. Let me show if I can show. This challenge was create a transfer hook vault. This challenge, this is the this is that challenge. Create a transfer hook vault that only whitelisted addresses can make transfer. So that is this one. So the first one we did was this one where you have just a token. You are creating a program that can create tokens, and people that are allowed to transfer that tokens are those tokens rather are people that are whitelisted. So you basically have a state that keeps track of whitelisted accounts, and you have your token. So you can mint the token in the program and transfer and have a custom PDA or PDAs that keeps track of the whitelisted addresses. So that was what this one was about. Trying to pull up the repository for that and everything. Let me check. Spirit the one. Then let me go to 2024. Yep. Yeah. I think it was whitelist transfer hook. Whitelist, not vault. Where's the vault one? Let's go anchor transfer. I think it was this one. Let me check. When I check, I'll see. Fogged from Andre and vice transfer hook. Let me just keep going. See bomb the text up a bit. From the instruction handlers, I will know what happened here. I'm just bad at writing docs. I should have written a doc. Okay, there is a readme at the front. I should have just read the readme though. Yes, this one has all of it has the transfer hook and the whitelist inside the same program, right? Everything was basically inside the same program. This is the solution to this one that we did right here. So let me just do a walkthrough over that how we did that. Right? Something simple. So in the instructions, let me check the librs. You see, let me just walk you through the whole thing that is going on here. I have a method to add user, add user to a whitelist, remove user from a whitelist. So you can see I removed this instruction to initialize the whitelist because I was doing a condition to check if the whitelist is initialized here. So if it's not initialized, just initialize it in the same instruction as add. That's what I just did there. Add to whitelist, remove from the whitelist, create. So now this one is the instruction to create and initialize the mint. So what is going on there? What I was doing here was I'm creating the mint and I'm initializing the transfer hook on top of that mint. Don't forget, you have a transfer, you have a token. Then you need to give the token superpowers or transfer hooks, basically. So when I'm creating the mint of the token and I'm adding those superpowers, so to say, which is the transfer hook superpower that I'm giving to this token, right? So that's what I'm doing there. Then we have the method to initialize that transfer hook. So what this is doing is now this is okay. Before I get to this, what this is doing is I'm saying that whenever there's a transfer hook on this token, you need to pass with the instruction. Whenever you're doing a transfer, you need to pass some extra accounts to this transfer. So that is what this is doing here. This initialize transfer hook is telling us, okay, on this transfer hook, we need to pass in some other extra accounts, and I'll go into that. We need to pass in some extra accounts. Let's say now, don't forget the task was to create a transfer hook that has make sure only whitelisted accounts can make transfers, right? So I need to be able to I need to be able to tell the instruction handler that whenever a user is making this token transfer, they must also pass in this whitelist address. So that is what this is about. You are going to initialize the extra account meta list. So if you are passing, let me go into that first before we go into source instructions, initialize extra account meta. Yes, this one. So what we are just doing here is this is the extra account you have to pass in from the docs. You see, blah, 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 blah. Yes, extra account must use exactly this seed, right? This one is just something we copy from the docs, right? It's not like we created it somewhere. This is a config that tells us what this is the derivation of what the extra account meta list account should look like. You know, if you are creating an account, you need to pass seeds, right? So this is the seed. This is the account that is the config that shows that okay, they are actually or they are actually hooks on this token. The actual extra account meta list on this token, right? So this is what you need to put this to make the instruction know. Oh, there is actually you're actually passing some extra account meta to it before you now proceed to add in those other things, right? So you need to pass in this extra account meta list, and so it's derived from this is extra account metas. So let me go back to what I was explaining. So that's it, extra account meta list, right? The extra account metas and the mint of the token. So the mint of the token and the extra account meta, just like in an NFT, right? There are different kind of NFTs from the metadata NFT, right? Not the core NFTs. There's fungible token, non-fungible token, fungible assets, like 4 or 5, I think 4 or 5. So based on if that account, that token has what's it called? Let's look it up. I've forgotten the name. Tokens, Metaplex tokens, take Metaplex, metadata tokens, Solana, not token extension. Everybody's talking about token extensions, right? I used the wrong keys. Token metadata. Yes, Metaplex. Is this core? Okay, this token metadata, right? So there are different types of yes semi-fungible token. You can have editions of tokens. There is programmable NFTs. I'm looking for there is a list. Is it on this doc? Token standards. Token standard field. Yeah. So yes, this is what I was looking for. There are different tokens based on if the token has is looking for the other accounts that you need on it. Example standard. There's this token metadata program, not that one, not that one. Okay, well, let me just explain what I was trying to point out. There's a different account that keeps track of the information about the token, right? Just like the metadata account. So that was easy to remember, bro. The metadata accounts, we have metadata accounts, and there are also other accounts that you can stack on each other to keep information about this token. If there are royalties on the token, who's getting the royalties? Are you printing different edition of this token? So all of that, right? So that's the same way, because if that account, if the metadata account is present, yes, this is what I'm looking for. It was right on the doc looking at me. So if a token has a master edition account, it is either non-fungible or programmable non-fungible. If the token has an edition account, so all these extra accounts that are associated with the token, if they are present with the token, the instruction handler will be able to determine what kind of token this is. So that's basically the same thing, similar to what's going on here with our transfer hooks. So if there is extra account meta list. That means this token has some transfer hooks, right? Simple and straightforward. So that's I just had to pull up another doc to explain what I was trying to explain. But you see, the more verify don't trust. So I'm verifying. I'm verifying what I'm saying. Not don't just trust me. I'll be saying something wrong. Yeah. So for the extra account meta list, the initializing this is I'm initializing the extra account meta on these tokens, right? So the bump, the space of the account. So the space that it will take is the space for adding this extra account meta on top of it. So that's not what we're talking about though. What I was going to point out was now you need to specify that for this token instruction, you must pass in this extra accounts. So now what are the extra accounts we need to pass in? This one, the first account you need to pass in is an account that is derived from this seed. So you could do extra account meta new with seed, extra account meta from address, this from address or with address. So just this one is a vector of accounts, right? If you have those accounts predetermined, you can put the accounts there. But if the accounts are deterministic, you can put the seeds for determining those to determine those accounts here. So now this account is determined by these seeds. So and the byte is whitelist. So basically, if you are making a transfer, you need to pass this whitelist account. So it's derived from the whitelist account and the account key zero. This account key index zero means the first account in the instruction handler of your transfer hook. So you must be able to derive this account, the account you're passing to me, you must be able to derive it from the seed whitelist and the first account inside the instruction. Which instruction? Inside this transfer hook instruction. Let me see if I can open this in a new tab. Yes, I can. Then if you go to the transfer hook, you will see the way the instructions are handled here. So in the transfer hook, we have this account. So we referenced that the token must be able to be derived from the mint and this is actually the token. So this is the address we're looking for, right? This address must be able to be determined, must be determined English, must be determined by this whitelist and a token, a token address, and the token address is the source token here. But inside this transfer, this extra account meta list, right? We do not, we're not passing all of those here, and even if we're passing it, we cannot access them here. So the only way to do it is tell the instruction handlers, I'm going to be passing you some account and you are initializing it this way. So any account you're passing to me, you must be able to pass in this key must be inside the account. So I'm setting it up once. I'm initializing it once. That any instruction you're passing to me, you must have an address which is derived from whitelist and also derived from the source token account, right? So now that's basically what I'm doing here. So that's the same thing that this one is about. But we derive from whitelist and the source token account. So the source token account in this place is the account at index 0, 0, 1, 2. So that was why we did c.account at index 0. Straightforward, right? It just take a while for you to get in, but you eventually get it. If you wanted to derive it from other things, like now another key, another public key, right? You will just put the key here if the payer is in this instruction now. So if you want it to be derived from just the payer here, you can use. Can you have access to payer directly here? I don't think so. You need to. Yes, you could. Yes, you do have access to payer here. But I'm indexing. I'm whitelisting the user token account. So I'm putting it there that it's the token account and the whitelist key that I'm using to whitelist this account. So that's what that one was all about. Then inside the transfer hook, now I was coming to this instruction transfer source. Let me get back to source. Then librs. Yes, we've talked about initializing the transfer hook, right? So this token has a transfer hook on top of it, and This account must be passed when you are interacting with the token. That's what this is about, right? So the next thing is the transfer hook itself. The transfer hook is the function that the method that is called immediately the transfer happens. Immediately the transfer happens. So once the transfer happens, you are calling this transfer hook. Now you see that now I'm having this instruction macros on top of it. Still macro, discriminator macro or whatever, instruction macro on top of it. And this one is telling Anchor that this is the transfer hook instruction. If we did not do it this way, if we not do it this way, it's telling Anchor that this is the account, this is the method that should be executed immediately a transfer works, right? So instruction, the discriminator is the execute instruction from SPL discriminator slice. So if we're not doing this way, we would have to do it this way. Oh, sorry, this way. They would have to put a this is the transfer work. Now you see on this one there's no instruction discriminator, right? I'm not telling the program that this is the discriminator for this instruction. We'd have to do it with a fallback. Where is the fallback? Where is the fallback? Fallback, fallback instruction. Yes, fallback instruction. Lastly, we need to add a fallback instruction to the Anchor program to handle the CPI from token extension program. So once a transfer happens, you need to CPI into your token extension program, right? And we will need to provide this fallback. And the fallback does check the instruction. If it's a transfer hook instruction, do this private global transfer hook. So just call this transfer hook function. This transfer hook function. So that's what this is. You would have to do this, but since there's a shortcut, why not? This is what aura farming looks like. It feels so good when you write this, right? Yeah. So that's about how everything works, right? You initialize the transfer hook, initialize your additional accounts on the transfer hook, then you have specify a transfer hook instruction, then you create the mint, add to whitelist, and or the example from this place is just a hello world example. So you see the amount of code you need to write just to print hello world immediately a transfer happens. It's crazy, bro. Yeah. Okay. In a minute, I want to bring in Hamza on the call, but before then, let's just keep jamming. Let's keep jamming. Let's keep jamming. Where am I? Yes, where was I? I was here, and I was here. Okay, so we've talked about how everything works together, right? You have the token, initialize the extra account meta you want on it, put the create the transfer hook function. What should be done immediately? The transfer works, right? Then what's that? Then the next one was this one. This one has nothing to do with transfer. This one was just testing out light FVM, right? So the next one was this fault. And let me pull up the program for that. That program is where was it? Where was it? Where is it? Minute to look for it. Mm, brave, brave. Sorry about that. About yeah. And I just did. Am I lost my screen? I just lost my entire screen. Where? Oh shit! I think this is what I was sharing, and I minimize what I was sharing. Program whitelist. Yes, this one. So I was doing before then, trying to show before this also. Before this, I can just check travel back to Yep, this is where I was going to. All right, so the next one was this is where we're coming from, right? Yes, the next one was this transfer hooks challenge. Yeah, I hope I not mess it up this time. Okay, I'm good. Okay, the next one was this challenge, right? The one I shared previously. And what the challenge was to create a transfer hook vault where only whitelisted users can interact with the vault. We've done that. Use a single vault means the token program. It's just amazing how these instructions are detailed, right? It means the token in the program, interactions apply to deposit and removing funds. Start by using a vector of whitelist, pub key, amount. I ended up using pub key, amount, and a boolean. I'll get to that. Then test everything with light SVM. We did. Add another extension of a choice. I did not. I have not. Okay. Then there's no unique solution. Uh, do what works for you as long as you get to this task. So as soon as I do blah 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 blah. Let's see, back to this. It's taking forever to load a single page. Okay. So okay, I even had what I just showed was staring right in front of me. I need to be more conscious of these things. Okay. So what we did now for this approach, like I said before, this is what we're trying to do. We have a vault and people that can transfer to the vault. It's just like a contribution system. Only people that you've onboarded can make contributions, right? So that's what it's about. Yeah. Where am I? Where am I? Okay, yeah. So now what we did was they said have a transfer hook and have a vault. You wouldn't put both of them inside the same place because of reentrancy issues, right? So that's why we have to add a program that deals with only the transfer hook. Then add a program that is the vault. So let me see which should we start from. Let's start from the vault. So where is vault? So instructions. Let me start from the lib so you get a bigger picture of what's going on here. So we have these instructions. Create the vault, mint your tokens, add to the whitelist, remove from the whitelist, deposit funds, withdraw funds. That's all. So something as simple as this needs like, well, it's cool, right? It's cool. So create vault, you mint your tokens, add a user to the whitelist. So this minting token is you as the admin, you want to get some of the tokens yourself, right? Or someone wants to purchase your token, you get some amount and you mint it to them over the counter, right? So whatever works. Remove from the whitelist. You do not want this person to you could that's remove from the whitelist is actually a deactivate user, not removing because I'm not deleting the user totally, I'm just deactivating the user. Now I just saw a flaw in my design. Yeah, we cool. I also saw a flaw in my design which I should did I do that? Did I? But this thing works. It works. It does work. Should I touch it? Should I leave it? I think I'm gonna leave it. What do you guys think? Should I touch it? Should I leave it? It's almost supposed to be a remove from vault, but I'm doing a deactivate user. I'll show you what that means in a while. So you can deposit into the vault and you can withdraw from the vault. So if you are depositing into the vault, you need to be sure that you're part of the whitelisted users, or else you don't deposit funds, right? Mm, So now let me walk yours through how I did. Creating the vault is straightforward, right? Just creating the vault. It's not rocket science, is it? Let me check. Instructions, create vault. So vault operations. I the name of the instruction is vault operations, sorry. And I'm accepting. Yes, sir. Thanks for staying. Thanks for staying, Greg. Mad respect to you, sir. So we have vault operations. We have Bob create vault. And inside the vault, we're just doing this vault of setting now, just basically creating a struct, which we have this account already now. Like we said, you don't store things on the blockchain. Also, and I store things on accounts that live on the blockchain, right? So we have this account that we created. They're called states. You guys know this already. Why am I rambling over these things? Okay, okay. If you'd like me to go deeper into what accounts, states, just drop it in the chat. Else, I'll just assume everybody has fundamental knowledge of what we're doing here. Right. And what else? What else? What else? What else? Create votes. Yeah. So I'm checking if this user, if it that no, I said I'm doing two instructions in one, right? I'm checking if the user already exists. If the account, the vault state is initialized. If the vault state is initialized, proceed to the next thing. If it is not initialized, no, this is not. I'm explaining the wrong program. I have two programs mixed up in my head. This is a create vault instruction. Why would I want to know if it's okay? Okay, yes, I want to know. Yeah, I'm checking if there is an owner inside this vault, right? So if there's an owner inside the vault, just say vault already exists. That means you cannot recreate the vault that already exists, right? What if you close the account? So the mint, the owner, and the vault bump. So we're just doing vault state vault.setting. Vault.setting is a shortcut for vault.mint equals mint, vault.owner equals owner, vault.bump equals bump. So just like we have this vault struct and we can set it inside the vault. It's just a straightforward way to create everything so you not miss out anything. If you're initializing an account, you might have like 7 states that you want to keep, 7 things inside the state that you want to keep track of, and you only put 6. That's your own flaw error, right? That's your flaw. So to fix that, you can just use the setting now. Setting now will require that you actually set a value to all of these things in the on the inside, right? So now, what else? What else? Create vault. And we have. Sorry, I was going to bring. My bad. I was going to bring somebody up to the stage, and I just went on talking and talking and talking. Bro, it's crazy. Yeah. So let me bring the person up to the stage now. But while the person is coming in, create vault, then instructions. This is what we're just doing in the vault. We're just creating the vault. Can I'm also am I initializing the token? Yes, I'm doing something very important. I forgot to mention. I said the steps is you create the mint, then you say what account you want to put on top of that mint. Let's say you want transfer hook extension. What extension do you want inside that mint, right? With Anchor, it's very easy. You can just do it like this: extension, transfer hook, authority is this, extension, transfer hook, program ID is this. This works in two ways. This one is with Anchor. If this is an initialize, if this is init, if it's init here, it will set these things automatically. But if this is mutable and you do this, it would check that this actually exists. To check that the owner is the authority of this transfer hook, and to check if the transfer hook program ID is actually the program ID that is set. So if it's a mute, it would check. But if it is an init, it will create it that way. The same thing if it was a mute that was here, if we had mutes, like we have, is there any place we have mute? Okay, I'm creating here. If we have like this place now, but if it's an account, a state account, if it was mute that was here, you would have this mint decimal will check that the mint decimal is actually 9, and this mint authority will check that the authority is actually this owner, right? But now we're having init, so it would set all of these variables inside the mint. So it's like idempotent. It's create if init if needed. That's not init if needed, but it does two things. It checks if okay, this then this. So I have to specify, since we are not creating, since this program is not the transfer hook, right? You know, if you're using a transfer hook extension, you have to specify the program ID of that transfer hook. That means what program should be called immediately a transfer happens. That this is where you're setting that, and that this is the program ID that should be called immediately this transfer happens, right? And this program ID is the hook, our transfer hook program ID. This is from okay, it's from here. Just right down here. Looking for something that was not lost. And I'm having an unchecked account. that says this is the program ID of the transfer hook on checked account. So I'm using the ID of this account here. So when I'm initializing this, creating the vault, I need to pass the transfer. That means I need to have created the transfer hook program, then pass the ID over here. So create transfer hook first, then pass the ID over here. Next thing, vault states. Vault states. That is the states that we're creating, right? It's an account of vault. Then the vault ATA. This vault state has authority over this ATA. The ATA is like I said, until now your tokens do not live inside your wallet address. Your token lives in an associated token address, right? Your wallet address is just a system program address that stores Sol. If you want to store anything apart from Sol on that address, you have to create an associated token address for that address. So now, since our vault also wants to receive tokens, the token will be now associated token account, right? So the vault associated token account is an interface account, token account. This is modern way of writing it interface account. Else you would have just done account then token account, but interface account makes more sense because we want to be able to. What interface account does is now we're using token 2022, right? You could have a fallback. So the interface account is can accommodate both SPL token and token 2022 tokens. So that's basically what that is. So if you're using a 2022 program, yeah, you can use interface accounts for any one of them. So it's not that you have to do token 2022 account. No, just token account, interface accounts. Then here you can specify the program ID of that token. Because this program ID now will be the token 2022 program ID. Right. So that's what interface account does. It's like a wrapper that can take either SPL token or token 22. And we have the system program, token program, and ATA program. What else are we talking about? Now, these ones are just basic stuff, right? I just explained what we're doing inside the vault. Then the next thing we wanted to go for is, I think, after creating the vault, minting the tokens. So don't forget, I initialize the token inside that inside the creation of the vault, right? So let's check what is actually happening in the mint token. So in the mint token, we have a instruction here, token account, that is token factory rather. The signer is signing for this transaction. Then the mint. Now we're not initializing the mint anymore because we have created it in the first instruction. So if we wanted, Anchor will throw an error here if this account you are putting here does not already exist, right? So if it does not exist, you can specify a custom error by just putting at something, right? You do mute at whatever. Did I do that anywhere? Yeah, when I get to that, I'll show just like having constraints, right? So you specify that this is mutable. Else, if it's not mutable, throw this error. Can specify specific errors for those scenarios. So mint decimal is 9, mint authority is user. That's basically what we did in the initialization, but we're now setting it here to make sure that the user is actually passing the actual mints that we expect. So without all these constraints, the user would pass any other token account. And since you're not doing your checks in your program, then you are sitting ducks, right? Next one, source token account, the sender's token account, the person that is interacting with this program token account. So since it's the person that wants to get the token, like the admin, to be the admin's token account in this place, because only the admin can mint token to himself. And this is innate if needed. Means if this account does not exist previously, I mean, if this is the first time the user is minting tokens to this account, create it. If it's not the first time, just reuse it that way. So that's what this innate if needed does, is like create idempotent. If it exists, do not create it. If it does not exist, create it. Then must specify the payer. If you are creating it, there should be a payer. Then other constraints. The mint of this token account, the associated token account, the mint of the token account is this mint that I provided here. The authority for this token account is the user, the admin, and the token program should be token 2022. That's yeah. I specify the program. I have to pass the programs also here. Then extra account meta list. So this one, even though we're not calling this one Um, we're not initializing it here, even if it does not exist initially, we are passing it here as mutable. We have created it somewhere, even if we've not created it, just pass it here. I don't think I'm doing anything on this account. I'm not doing anything on it. Yes, this is redundant. I did not need this anywhere, but I added it anyways. I think I said it last time too. I've not gone back to edit this. So the block list is our whitelist. That's the account I will create from the key whitelist. Don't forget this one. I'm just creating the key whitelist. I'm not doing whitelist and address. I'm just doing whitelist. So it will be easy for me to create it in the it will be easy for me to whitelist to initialize the token extra account meta list because I'm only using the key whitelist. If I go to my meta list now, meta list. Okay, before I go there, I'm just minting the tokens to the admin. That's just what I'm doing. CPI context the new, and I'm doing a mint to checked, and I'm minting the token to the admin. Simple. I was going to explain initialize extra account meta next. So let me go to that real quick too. Initialize extra account meta. So now you see how straightforward it is for me here. I'm just doing seed literal from byte whitelist. I'm not adding account at index 0, account at index 1, or account at index 2, right? I'm just doing this. That's straightforward what I'm doing. So the design, so it depends on your design. You are the engineer here, right? First thing that you want to do, if you are making any projects, you want to have a design structure. And let me see. I think I have something similar on what do I use? What do I use for architectural diagram? Draw IO. Yes. I go to draw IO. I hope it's still in the cached state. Yes. You want to know this one is for a program that I did. I don't even have the architecture diagram here, right? But you need to map out. Let me zoom in. You need to map out exactly what you want. You need to know what you are doing first before. So you're not just start writing code. Then figure out, oh, this is not supposed to be this way. Then you go back and edit code. That will take you days. Something like you could have done in like hours or like a day if you have this. Without having a roadmap before you start writing code, you will spend days trying to figure out what is actually happening. But either ways, you are going to have your solution. So I have this platform. I specify. Okay, there are different accounts here, right? This is the platform. This is this. You just want to specify every single thing that wants to happen inside the instruction, right? Is there a similar one? I think there's. Can you show recent? Open recent. Uh, it was not on this account. But you need to first map out what are the user stories, like user stories, right? What are the user steps? This guy can do this. This guy can do this. This guy can do that. You need to know if a user is coming in as a fresh user, what should they be able to do? So once you've written everything out, and you have to write that out. Let's see now. Platform shall collect fees on listing. Let me increase the font size of that. It says platform shall collect fees on listing of creation. Platform shall collect fees on purchase of shares. Platform shall collect fees on buyback of shares. So you don't want to write platform shall collect fees on listing creation and purchase shares and no, map it out. Give your mind more space to do these things. You need to think technically. Yeah? We'll have a very good session. That's a good idea. We'll have a session on architectural diagrams soon. Maybe I don't think that's Monday, not Monday, maybe some other time. I have a session on architectural diagram. So you know how to write your architectural diagram the right way. I'm not the best to talk about this, but I can write architecture, but someone more professional in that sense would do the session. Could be Beg, but Beg is not this call anymore. I've loved him too. Could be Beg. Anybody will just come up, show you exactly previous architecture diagrams they've done. I'll show you how to do. Okay, I think I have one example. Yeah, if I go back here, let me just come to GitHub. Repositories, bro. No, not repositories. Overview. And I come to, yes, and I come here. This was my Q3, that's last quarter's turbine builder session. So my capstone, this have this is what an architecture diagram looks like. Even mine is not still detailed. It's not so detailed, but it's simple enough to understand exactly. This is for an NFT marketplace, but not an NFT. It's an NFT marketplace, but an RWA marketplace, which is tied to NFTs. So it's still basically an NFT marketplace. It's still loading. It's still loading. Oh, is this an image? Oh, sorry, it's an image now. So let me open it with Draw.io. I use Draw.io. You can use Excalibur, but Draw.io feels more rigid than Excalibur for making this kind of things. So, like I said, you map out what you are doing. So this was not even part of what we're supposed to do, but just divert it, right? Protocol, what will the protocol be able to do? Protocol shall deduct fees. What will the admin, if there will be an admin? So all those entities that will be involved in your program, map them out. The assets shall be non-fungible, shall supply shall be more than one, all those stuff. So you have something, a guide when you're writing your programs, right? You don't just want to jump into writing code. Have steps. So now you can have this again. This should also be there. Just walk us through what's going on here, right? Step one, initializing admin initialize the marketplace. Is the marketplace initialized? No, do this. So you see, this same thought pattern is what I did here. I cannot just jump into writing code without mapping it out. You have to know what you are doing, right? So this is what for that. This is you knowing what you are doing in detail, right? So I'm now giving instruction handlers to those. Step one is what is happening in step one. Admin initialize marketplace, admin sets of the marketplace infrastructure. So what are the things that will be happening in those steps? Simple. It makes you look professional, right? It makes you feel good writing what you are doing, basically. And if you want a link to what that is like, let me just share. It's not editable. I think it's read only. You can just have. Let me drop it on X. I don't have X on this account on this place here. Let me open it here. Yeah, sorry for the break. I'm back. Let me show present my screen. Yeah, my screen and I was trying to share that when Chrome froze, so I had to run away from Chrome, guys. Chrome just clocked my CPU. Escape. Let me do. Let me see. Let me see. Let me see. Trying to pull up my system monitor. So no, I'm on a 12 CPU PC and Chrome just clocked every single like Chrome will take whatever thing you throw at it. Am I still live now? Let me check. My live now. My live. Drop a chat if you can see me. If I'm back to the stage, drop something in the chat. Sorry. Mm, so if you guys can see me, let me do it. Oh, where we at? Yep. Okay. And all right. So we were explaining draw IO sold draw IO whitelist transfer. Okay. Let me just get back to explaining. I was trying to drive a point that you need to articulate what you're doing, right? Have a flow to show what you're doing, right? So that's what I was trying to point out there. Let me get back to repositories. No, overview, no repositories. Then yeah, transfer hooks challenge, one challenge, one challenge program challenge. Source instructions. Yeah, I just finished explaining initialize mint now. Is it mint? Deposits. Okay, yes. Mint. Before I digressed. Yeah. So I'm just minting the token share, right? So let me get back to the instructions source. In my librs, the next thing in the instruction list is or at least deposit. Is it deposit? Is it deposit? After creating the vault, you mint your tokens, then you can add a user to the whitelist. This is a tricky part because of the way the program is organized, right? So let me go into the program state. What's the program state? So you see what I'm actually doing, the state of the program. Yeah, whitelist. Yes. So the whitelist is a simple whitelist struct. This is people that have been here since last week will be tired of this already, sir, because we've been over this time and time again. But let's go. Address is an address of is a vector of addresses. The address here is storing a vector of address, the amount the user has, and if the user is whitelisted. So that's the implementation I'm going with. And whitelist bump, admin, pub key. So, and I'm having a helper function, right? Whitelist. If the user contains this address, if this user is existing in the whitelist, right? So if the user is not existing in the whitelist, that means obviously the person not whitelisted, right? Just throw false, and you know how to handle it on the other side. Then now, if the user exists but the user is not whitelisted, we need to be able to find that also, right? What if the user is in the whitelist but the user is blocked from making transactions at that moment? So we need to be able to handle that also, right? So that is what this is whitelisted is about. So then let's move from vault, deposit, withdraw. So the deposit is now, like I also explained what did not work for the deposit and what worked. The source. Then let's go back to test. No, not test. Instructions. Deposit, withdraw. This is where things get interesting. So I'm using a SPL 2022 token. Let me just share this now, and I hope Chrome will not mess up again. I just hope. Oh, it's that storm coming. I hope Chrome doesn't mess up now. It should be look one test. Oh, yes, let me get you the link. The link to this. And I open Chrome with my fingers crossed. Let me show you Chrome. I just opened Chrome now, and you will see what happened to my CPU. Look at what happened to my CPU. Yeah. Look at what Chrome did to me. Bro, it's crazy, bro. It's just let me do share it on X, and over here I would reduce. Let me get back to share what I was sharing. Yeah, and in the chat I will just send. Or let me send it over the chat here. The chat over here. Yeah, just transfer hook challenge vault plus whitelist. Yes, I've added that in the comments there. Let me share it also in the chat of this live stream. Then if I come back to studio, I can pull it up here. So if you want to see this is that. This is the GitHub to what I'm explaining now. If you want to check it out and work with it, play around with it, and hmm, so in the deposit and withdraw, we have an instruction handler like this. Our account structure rather. The sender, the signer, the owner is the admin of the platform, the mint that we're interacting with. So yes, what I was trying to explain before was this. You could have you can have this constraint, but I have if it's mutable, I do mute. I can put this error beside it. I've defined this custom error. So now the constraint I'm looking at is the mint authority must be the owner. Yeah. So if you have that wrong, if you're passing a wrong account, just send wrong authority, right? You have to make sure you are doing all those checks, conditional checks, right? Excuse me. Then what else? 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 Hook program ID. That's the idea of the transfer token, the transfer hook, right? The vault state, we know what that is. Vault ATA, we know what that is. User ATA, we know what that is. That's the sender's ATA. Now, this is not the admin. This one is the person interacting with the platform now. So now we have different users. First user is the admin. Second user now, secondary user is the uh the person that is sending money to the vault. Yes. So this is the person's ATA. Then the whitelist, extra account meta list, then other programs that we need, right? So deposits. When you're depositing, I'm not that using this since I can just pass in all the accounts I need here, like extra account meta list and whitelist. These are the only two accounts I need, right? I can just have I can just pass them here instead of having it like remaining accounts. Right. So I will remove this. I cannot leave it there for fancy. So require first thing I want to require that you're not trying to transfer more than what you own, right? Why would you want to do that in that anyways? Then I'm building the transfer check instruction. But this token instruction, like I said, if you were using Anchor SPL token instruction, it will not work. Anchor SPL 31 does not have the capacity to transfer tokens that have token hooks on them. So you cannot use that. You need a special SPL token 22 crate. So that's what we're using here. SPL 2022 create. Then you can use the on-chain method or you can use the instruction method, right? The on-chain method is, I'll show that. You can use the instruction method. So the on-chain method is like something like this. It's failed, but I know why it's failed now. On-chain instruction, then invoke transfer check, and just passing all those things, it would work. But what since it did not work for me right out of the box, I had to improvise. I even tried using the normal transfer check, like I said, and I tried to pass remaining accounts. Yeah, still did not work. So normal SPL, Anchor SPL transfer check does not work yet, or maybe I'm doing it wrong. So what worked for me was building the transfer like an invoke function. So the transfer instructions, yeah, then there are accounts that are needed for this instruction to. So it must be in the same order. The user ID, the first account is the source account, the main, vault, sender, token program, extra account meta list, white hook, and we need the whitelist and the hook program ID. So these are the two these extra accounts that we needed. So we have to pass those two, right? And the invoke transfer instruction, just invoke it, basically invoke, and we are done. So that would transfer, that will make the transfer, and all the transfer hook side effects will be checked inside your transfer hook program. So what I'm doing here is just assigning how much was transferred to the whitelist address. So when you're trying to withdraw, you cannot withdraw more than you transferred. I'm doing that here. So entry block, I'm just doing that here. Withdraw is the opposite. So let's quickly go into the transfer hook program before we move on to requirement tests. Transfer hook program, transfer hook source distractions. So let me get to the lib. I like checking the lib first. So you see exactly what's going on in the transfer, right? In the instruction. Yeah, source. In the source, then we have lib. Yes, inside the lib, we have this is like we said, the instruction discriminator to tell this program that this is a transfer hook. This I might call this whatever I want, but this is the discriminator that you should execute immediately you sense a transfer on this token, right? So CPI has a blah 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 transfer hook, blah blah blah. So we'll get into that too. And this one is initializing the transfer, like we saw in the first place, initializing the extra account meta. So now let's get to the transfer hook itself. Source instructions transfer hook. Yeah. So this one is okay. The crate I'm using the transfer hook accounts source mint destination owner extra account whitelist. Like I said, this is the order that the transfer is coming in, right? This is the order it's coming in on. So yes, pub transfer hook. I'm doing check if it's transferring. This if it's transferring is an extra function that we have here. So source info is self dot source token dot account info. Just checking, then we're unpacking this account. This is the source token, right? The person making the transfer. We're getting the account of the person making the transfer. Then we're unpacking it to see if you are transferring. But when you are transferring, you are going to set a state that I'm transferring, right? And you're going to send that account because the account is writable. You're going to send the account to the destination that is going to remove the money from you. So, like I said, so long as just like a big file system, like a Linux file system, right? You can write to it. You can read like a file. You can write to a file. You can read from the file, like a paper that I can write to and read from. So inside this account, you have the state that checks if this account is actually transferring. The account itself is carrying the information. Am I transferring at the moment? So you can check, get extension mutable, transfer hook. Because of the transfer hook, is this guy transferring? So a boolean from account extension transferring. So I can get if it's transferring or not. If it's not transferring, panic not transferring. But if it's transferring, so self check if it's transferring. If it's transferring, so we're now getting the whitelist account from the whitelist. Then we're checking if the whitelist account contains their address that is being sent. No, the beautiful thing is inside this whitelist account, we have helper functions, right? That checks if contains address is whitelisted. That why Rust makes so much sense in that way. You can have implementations on those things. Like normally, I don't like using OOP classes. This one makes more sense. Implementation structs, implementation struct traits makes more sense than classes override. Crazy. And I prefer functional to OOP. So that's basically what I'm driving at. It's actually whitelisted to check if it's just like if you're a React person here. How did you feel writing OOP React versus React with hooks? How do you feel writing it? You see, it feels better to write React with hooks than React with classes. So that's the same way. Classes, but if you are writing C++, you can do classes and all that. C++, rather, there are no classes in C. So if the account is whitelisted, I just rambled on about something that's not supposed to be mentioned in this because it's not even in the context of what we're talking about. But yeah, checking if it's whitelisted. So if the user is actually whitelisted, you can perform blah 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 blah. Okay, if it's not whitelisted, then you panic. So revert the old transaction, play it back to the beginning. None of this happened because you are not whitelisted. The reason why you can have a different program attached to your program is because Solana transaction state is atomic. You can roll it back. Let's say you have a list of instructions, like 10 instructions now. If 9 of those instructions passes and the last one fails, you are roll back all the states like nothing happened. Right. So that's you can stack instructions on top of each other as a single instruction, and if one fails, reverse the whole thing. Beautiful. So now that's why we can now have this extra transfer hook instruction. But if it fails, play everything back from the beginning, right? So that there you have it. I just explained Excalibur, Excalibur, Excalibur. Just explained what we have here. Right, straightforward. Let me take this down. And what else? What else? What else? So now let's get into what we wanted to talk about today. This is part of what I want to talk about. I want to talk about sign off on token extension. Then I want to talk about VRF and ER. So the beautiful VRF and ER. Head over to Magic Magic Block. What is Magic Block? So first in the ER, let's check the ER. Any Solana program can be upgraded with ephemeral rollup by adding delegation capabilities. What this means is just this is a quick start. So you not panic that am I going to write something different? What is an ER basically? An ephemeral rollup is a I'm looking for one word. Is this word the meaning of the word ephemeral? Ephemeral means happening in a short while, right? It's a short time state. Yes. A short time state that can execute things, a short time state that can execute things and replay those things back to Solana, right? And executes, let's say, let me be a practical example now. What you are doing here is you're writing your program, you delegate the state. Delegate means I'm changing the authority to Magicblock. So Magicblock can perform. The reason why this is a thing is because number one, speed. Magicblock can perform. There is a okay overview, not a from a roll up white paper. There is one beautiful doc before we get here. Let me just check normal Magicblock. This is the docs. Let's go to magicblock.gg. I want you to see that beautiful thing that's there. Magicblock.gg. I hope it's the right thing. Magic block. Or is it just the docs? Is it just the docs? Magic block Solana. Magic block.xyz. Yeah, see. That's why I was not working. So you have this beautiful website. Real time engine for decentralized applications. So that's what I wanted to point out. Yeah. Sub 10 millisecond for transaction. Normally on Solana, the transaction goes like 400 milliseconds, right? Takes 400 milliseconds to execute and confirm a transaction, then move on to the next thing, right? But on Magic Block, takes 10 to 50 milliseconds. That's like, I don't even know, 40 times faster, right? 40 times faster, yes, like 40 times faster. If it's on 10 milliseconds, like 40 times faster than Solana. So how it works is, so zero latency, 1 millisecond block time, and 50 millisecond end-to-end text to location. So how it works is you have a transaction, you have an account, right? So the thing is, one misconception that you should not have is thinking Magic Block is an L2. An L2 can exist on its own, right? L2 can exist on its own and return transactions back to the L1. But Magic Block is not an L2. Magic Block is it says a roll up, right? But it's ephemeral. It's happening for a short period of time. So you take the state that you want, the state account that you want to work with on Magic Block, delegate it to Magic Block. Like, yeah, you are the owner now, and I can now interact with you. I can interact on the account, do everything I want to do on the account very fast, like within 10 milliseconds, right? Do everything I want to do on the account very fast. And when I'm done, I can undelegate back to Solana. As simple as that. So with this way, you can now specify like other features that are there can help you specify, okay, I want transactions to be gasless for my users. So it opens the world of possibilities for DeFi, right? I want transactions to be gasless because it's like it is not on Solana anymore. So it is not you don't have to use Solana, you don't have to spend that gas fee that is required by Solana because no longer at that instant they are writing to the account. It is not on Solana, it is on a machine that is 100% compatible with Solana. It is the same Solana SPL, Solana system program, this exact same thing as Solana is, but it cannot exist without Solana. That's come back and bring those information back to Solana. Just like an L2, right? An L2 have instruct, you can make a transaction on L2, then sometime in the future, it comes back. But this one, everything is still Solana. This is Solana, but outside of that Solana state at the moment. If it makes sense, if it does. Because now I feel like hearing myself say that it does not make sense. Yeah. So this is an example of a counter. Initialize the counter just like you would with Anchor. So increment the counter. This is like just a basic Solana example. But the first thing that you should notice is this ephemeral. Give me a minute. It is raining over here. Let me just do this 1 minute. Sorry. Yeah, I hope you can hear me better now. Better now. I hope it's better now. It's raining cats and dogs outside. Okay, so I was explaining Magic Block, right? This ephemeral on your program indicates that this program should work well with should work with Magic Block because Magic Block is ephemeral block. So this injects everything that Magic Block needs inside your program. It injects it inside the program, right? So I'm just trying to explain what Magic Block is before I get into the task at hand. I don't know if I should scream because I can still raining out here and I can hear myself talk. I don't know if you guys can hear me though. the incubator, what is the power of Magicblock? Okay, all about that. Solutions, build, docs, back to the docs, ephemeral roll up. I think that's what I also ephemeral roll ups. There is this very good um okay how it works. Yes, how it works. That's what I'm looking for. Delegation, commitment, on delegation. So delegation is like you're changing the owner, right? You're saying Magicblock should be the owner of this account. Then whatever changes you're making, you can commit it. Just keep committing it to the ephemeral roll up. And after you're done with all the changes that you want, you can undelegate back to Solana base layer. So ER operations to the ephemeral roll up, back to ER operation, then to Solana. There is one I was trying to look for. Blah, 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 blah. There is one. Okay, I think it's this one. Across material. There's this illustration, the benefit of Magicblock ephemeral lock, gasless transaction. So zero fees enabling scalability and mass adoption, right? Faster block time that's less than 10 millisecond latency. Higher precision scheduling. So um, your you can schedule automations, can make these things automated, right? And schedule instructions, transactions, what I was looking for. Program, I think internet is killing me. Program and state synchronization, fragmentation, composable and available, horizontal scaling, familiar tooling means you can write this thing with Anchor, something you're familiar with. Not with Anchor, meaning Anchor, but you're familiar with Anchor, you can use it with Anchor. You can use it with basic, with normal Solana program also. Vanilla Solana, you can do that also. Then you could use, I think you can use the Pinocchio also. Anything you're familiar with, right? It's just Rust, still Rust. So the ephemeral roll up. I hope this one have that illustration I'm looking for. Magic is it a magic router? Magic router. Let me check magic router. Is it locked? Is it locked? Magic router is locked. You didn't remove that thing from the dock. Fix that, for example. There's this dock that shows how fast it is. Let me check if I still have it here. 1 minute. Sorry. What's this? I'm looking for one. I think I took screenshot of it. Let me see. Hopefully I still have it. I did remove it from the dock. Or is it not just me? Is it me that I'm not patient enough to look for it? We shall see. Shall we not? We shall see. A minute. A minute. A minute. Sorry. Magic block. Magic block. Magic block. Magic block. Magic block. No, I don't have it anymore. But that okay, I have it. I do have it. Yes, how it works. Yeah, this is what I was looking for. How it works. This thing should be on the dock. I don't know why it's not on the dock currently. I mean, increase the font size. I hope you guys can see me well because it's raining everywhere. I think I just increase my microphone so you can hear me well now, hopefully. So that's how it works. The user sends a transaction and based on if it is the account has been delegated to Magicblock or not, it uses Solana or Magicblock RPC. So now first block. So every 10 milliseconds, like every 10 milliseconds, the next block is created, right? So first block here, the next block after 10 milliseconds, next block. And don't forget Solana is 40 milliseconds, right? So that means you can typically have 40 blocks inside of one So sometimes you can have, now you see how fast this is now. You can have 40 blocks before the next block, before the next Solana block. So it is like gives this fragmentation, fragmentation the right word. It gives this better way, faster, yes. It's closer to real time execution. They're still trying to get it lower than 10 milliseconds. But with the way it is now, you can have 10, 40 blocks. You see how crazy fast that is? So by the time you get to the third block on Solana, you're already 80 blocks inside Magicblock. Yeah. So don't forget to delegate. Then you make changes, you commit your changes, can commit it back to the next block. So and the interesting thing is the state of this your account are still readable on Solana, but it's locked on Solana. That means another user cannot, you cannot write to it outside of Magicblock because you have given the authority to, have delegated the authority to Magicblock at that moment. So for you to write to write to that account, you need to write to the account through Magicblock. Right? Magicblock will be the delegated owner at that moment, right? So at every so on Solana is readable, but it's not writable on Solana until you undelegate back to Solana, then it becomes fully writable on Solana. Yes, the rain has stopped a bit now, so I can reduce my microphone back. Oh, okay, so this is what I was trying to look for. This is the doc I was looking for. Then let's go to code. Let's go to code. This is typically what. Let me see. Let me try to close this to close this. Okay, the document. Solana. Then where is it in Pinocchio? It's in Pinocchio. Put anchor programs in Pinocchio. Then yes, let's see the magic block ER VRF. I don't think we'll be able to cover everything on this call, but here's what I was trying to do right before the call. Get to this program source states. Let me start from the states though. No, no, not state rather. I meant lib. So, but let me since I opened state already, let me just show what state is. So, in the state account, I have the user, the data that the user is keeping, and the bump of that user of that state account, and the space for it. I could just derive in it, but Andre decided to do this. 32 bytes for the pub key, 8 bytes for data, which is a U64. The bump, then what's this? 8 bytes for account. Okay, 8 bytes for the account discriminator. So the bump is 1 byte, then 8 bytes for account discriminator. Right. So that's basically the space that is required uh, for this account user account state. So the instructions that we have basically initialize the user state, update user state, update and commit, then delegate, undelegate, close. So the other thing I was doing was putting randomness inside of it. So instead of just me saying I want to add five, I want to change update user state, I could just get a random number and put it inside the user state. So that is with this other thing on the docs. So there's another product called verifiable randomness function. So request consume verifiable okay, I'm back now. Okay, the internet messed up the internet. So I was talking about VRF, right? Verifiable random function is, you can have an instance where you need something that is random. You need something random inside your program for any reason why you want to do that. Let's say you are making a dice game, mostly using games, not only games, but let's give an example for games. Maybe a dice game, cards game. You want something random. You roll dice and you want I know you don't have to, you don't predict what values to show, right? If of the dice, it could be heads, it could be whatever numbers it is, or flipping a coin, it could be heads or tail. You don't predict that, and you cannot do that on the blockchain because originally you cannot do that on the blockchain because how do I put it? If you try to the way blockchain works, the blockchain is deterministic, should be deterministic in the sense that if I confirm this transaction, this validator confirms it. The next validator, all validators should be able to confirm this transaction and get the same hash. Like they need to get the same state back. Let's say my transaction now, I'm sending 20, so 20 sold to this person. So when I send 20 sold, the state of that person should be exactly as when someone else tries to check that transaction, and they must be able to see that it's 20 there, right? So what if I want to send a random I want to send a random amount. Like I just think of a number, click a button and send the amount. If someone else wants to replay the transaction, like it must happen at at that same way. So they'll be able to come to a consensus and say, oh, everything happened this is decentralized and everything actually happened the right way, right? Because it is random and the instance I'm getting here, if I run it on my machine, it cannot be the same thing as the instance you get when you run it on your machine because that's the meaning of randomness, right? So that randomness makes it impossible for it to happen on the blockchain because you cannot validate that something is actually the right number because you end up getting different states. So I cannot conclude in that block because they have different states for the accounts. So all the states must be the same for their accounts, right? So if I play the state in my account, my validator it must show that state. If I play it on this other validator, it must show that exact state. So all those states must be actually the same thing for it to for the centralization to be possible, right? So but with randomness, if you have something random, there's no way the other person machine will derive something and they'll still get that same amount, that same value that you got since it's random. So there's a way to do it though with VRF. You can verify you can request randomness on chain. So process of requesting and consuming on chain randomness. The way it works is this. Let me just give you a brief an overview. In your program, you do specify a seed and you call for randomness. You're not creating the randomness on your laptop on your machine, right? You call for randomness and you specify the fallback. Specify what should be done, which instruction should be done immediately your random number is gotten, and that callback will hit that callback function. That's just basically. So I want to set the state somewhere else to be 24, to be whatever. Let's say the random number is 24. I make a call to request a random number. Immediately I get a random number, it saves it. So I'm not the one generating the randomness. I'm fetching the randomness on chain with a seed, right? Then once it gets that random number, it now does whatever I call it in the callback. So this is an example of this roll dice example. So now write your program, a simple roll die program where players initialize state account to store, request, and consume randomness. So we have the initialize normal. So this is what the state of the account looks like. We have one account state here. This is the initialization account. This is the state here. The user state is called player. And inside the player, you have last result, which is a UH, just a number, right? A player account that stores number. Then you have two important functions. The random, okay, this one is not that one. This is not. Okay, this is the base structure of what it looks like, right? Initialize function is just saying nothing. It's not just a regular initialize function. It's doing nothing, just saying sending a message. These are the two states you need. This one and this one. If you want to do a normal counter example, these are the states you need, right? So now you have your counter example. Assuming it's a counter example, then if you want to modify it, this is where things get interesting. You install all of this ephemeral VRF SDK anchor. So like I said, you can use it without if you're not using anchor, you don't need this anchor. But if you're using anchor, you use this ephemeral VRF SDK instructions, ephemeral VRF SDK types. So these are all the things you need. Then you add it to your program. Cargo add ephemeral VRF SDK. Then specify that you want to enable their anchor features. So add instruction roll dice to request randomness. Don't forget I said you request the randomness and you specify a callback that should be it once that randomness has been verified. You specify the next function that you will just like we did in our transfer hook. On every transfer, there is a fallback function, a transfer hook function. So on every request of your random number, there is a fallback to get to it to finalize what you've requested, basically. So roll dice example is taking the context do roll dice ctx. This is the context do roll dice. But specifying that this is a VRF account struct, right? It should have the VRF injected functionalities. You'll see that in a minute. The person paying for it, the seed of the player, then the oracle queue. So which account is this oracle queue? There are default oracles for Anchor. You know what an oracle is now? An oracle helps you fetch off-chain activities and bring them on-chain. So that's what this oracle is doing. That's basically what an oracle is. You can check if if a match is going on, if Man City scored a point, if Man U scored a point, that is what an oracle does for you. Can help you bring those off-chain events on chain. So there's an oracle queue, and this is the key. The address of the oracle is this one, the default queue. There is the default queue. This one is the default queue. There is the ephemeral. Okay, there's the ephemeral default queue. This one is the normal default queue. If you want to get randomness inside an ephemeral log, there's a different address for that. But you'll see that. But let's just get this example running first, right? Then derive accounts, another account, callback roll dice ctx. So once you've made your callback, once you've made requested for the randomness, you need to specify what what instruction will be called next. So to call that instruction, you need this account passed. And we'll get to where we're passing that to in a minute. So the callback CTX is taking in the identity of the VRF and the player account. So when you come, yeah, so the first instruction was requesting the randomness. When you roll the dice, you're requesting the randomness, right? Create randomness instruction while importing this from Magicblock. I'm importing this from Magicblock, right? Then these are the accounts that are needed, the parameters that are needed. So the player account, the Oracle queue, we're already having that. The program ID. So the program that will be called after you do your initialization, after you get your VRF back, what program should be called? So that is obviously your own program, right? So that's the ID of your program here. Then the discriminator, what instruction should be called after you get that randomness, that random number? What instruction should be called? The instruction is the instruction of call back roll dice. That is this call back roll dice. That's this instruction. Yeah. So you're telling it immediately you get this randomness. Immediately you get the randomness, then call back this function. And what is the callback doing? The callback is just assigning that random number that you got because it will give you a random number. So you don't eat this function. The only function you are eating is this function roll dice. Then immediately it is done, immediately it gets the random number. And you're also specifying, like I said, you are going to specify what accounts do you need when you are calling back. So when you are calling back, you need to always specify this account. You're telling Magicblock that when you are calling back into my program, I'm expecting you to pass in the player account back, just like what we did in transfer hook, right? So this one is called serializable account meta. So that is why in our callback roll dice CTX, we have the player account. It will pass this anyways, the signer, but it will now pass in this account. We need this account because this is where we are saving whatever we're changing on chain, right? We need to pass, we need it to pass this account when it's coming back to call our account. So that is what that is about there. What is it? Callback discriminator is the discriminator of this function, of this method. The discriminator, that means the ID of the method. Every method has an ID, 0, 1, 2, 3, whatever ID it is. When you are, you know, your program does not speak English, right? Your program speaks ones and zeros. So there should be an ID for this function. You know it as callback roll dice, but your program does not know it as callback roll dice. Your program knows it by its ID. You need to specify the ID of that, and by specifying the ID, this is what we do: instruction callback roll dice discriminator dot vex. So this is the ID of that transaction that should be called, of that instruction that should be called, the method that should be called rather. The caller seed is your client seed rather, your seed you specify. Now for something to be random, you need to have a point of randomness. You cannot say no, everything is subjective, everything is relative, right? If I'm saying, like, someone says give me trying to look for, I forgot how guy put it. So give me a lever, yes, give me a lever and give me a place to stand and I'll move the earth. So this is your place to stand, right? This is your own perspective. You need to give us something to work with. You cannot just, we need to know what we are working with, like I said. So if the next validator want to replay this account, replay this instruction, they need to know what to work with. So they're telling us this is what I'm working with, right? So whenever you give me this and do whatever you want to do with it, then you give me back my randomness, right? So this is my place to stand before I'm moving the earth. So now you're passing in this client seed here, yeah, as the caller seed. Then you specify the extra account that will be added to this instruction when you're calling back to it, and that's all. Then you do ctx the account dot invoke sign VRF, then okay it. So this is the callback function, and that's basically it. So you guys should try this out. But let me show you what before that. Let me show you what I did there. So this is a very messy code, by the way. I've not cleaned this up. I'm still trying to work on the tests. So let's go to the tests then. This is no, not this. I want to write latest VM test for it too, but for now I'm still testing with TypeScript because the repo had TypeScript test already. So writing your test now. There are, okay, before I get to that. Now, don't forget the ER is not Solana. The ER is on Solana. The ephemeral roller has its own RPC that connects to it. So when you're writing your test for an ER program, you need to have two RPCs now: the Solana RPC and your ER RPC. That is what this is about. This is the RPC of the ER, and this is the program in the program instance of the ER. Program instance is connecting to the RPC of the ER. So the program instance of the ER and your own Solana program instance, that's Anchor, Anchor provider. Now we are passing in a new connection to Magicblock RPC. So that's because we need it. If you when you are doing your when you are creating your account, okay, I'll just show you. Let's walk through it together. Initializing your account. This one is outside. This one is outside. Outside your ER is on Solana, right? You don't need this. You don't need the ER. For this one, you're just doing a direct program with Anchor method. This one is just your Anchor program connected to Solana, right? So this one just do direct initialize there. So updating the states too is still on Solana, right? direct program methods, right? Now, delegating it to, you are still on Solana, because it's from Solana that you delegate to the ER. You are still on Solana program method. Now, but updating the state of the account. Now, you are using your program, but the account that you are passing is no longer the account that is existing on Solana now, because you've delegated that account. Let me come again. Now, this is the user, right? This is the user account. Me making the program, me interacting with the program at that moment. That's the, like we said, instructions. Let me do which instruction is that? Okay, let me just do the basic. Okay, it's a state. This is the user account state. The user interacting with this program, the first one I'm trying to point out. Let's do init user here. Initializing the user now. This user is a Solana account, signer account, right? All good. You can pass that one here when you are delegating it. This is the user account. This is the user that is signing the transaction. This is the transaction account, right? This is the validator that we're interacting with. Then, next thing we need to do is when we want to update something that has been delegated, the account is no longer controlled by Solana. So if you put a direct Solana account here, to feel telling you uh, something does not own this program, account is not owned by program, because you are no longer this user now. When you Let's go and check what we did inside delegate, so you get a better uh, delegate, taking the user as a signer, the user account, that's the user key and the string user, validator, which is not dangerous because we don't read or write from this account. Okay, so it can be unchecked because we're not reading or writing from it, we're just specifying it. Then system program. Inside delegate, what we're doing is this is the seed of the user, of that user account, right? Then we're doing self.delegate user account. The user account is the payer is the user, the seeds of the user. Then a config. What config are we doing? We're doing a delegate config that's taking in the validator, the key of the validator, and the default config. So this is the account that we're delegating. This account, the account will be derived from this. You see, we're not specifying the account now. We're not putting the account directly. I'm not saying user account. Because if we said user account is derived from the program ID, from this program ID, right? But when it's going to Solana, when it's going to the ER, it is no longer controlled by our program. So you cannot derive it with our program. We derive it to our program. We are the owner. So you need to delegate the seeds of the account. So it will be able to recreate the account on the ER with the seed that you provided, right? So it's the seed that used to create the account, right? So to recreate that account with the seed that you provided, not recreating, it will derive the account rather. It's not creating, it's deriving the account with the seed you provided. And yeah, that's what the config is. If you want to put some frequencies on it, let's say recommit this thing every whatever millisecond, what validator, other validator that you want to use. So that's what the config is for. But you can just use the default settings. What the default settings? The default is the default. Okay, max 32 max. 32 max is 32 1 times 10 to the power 32 1 times 10 to the power 32 minus 1. So it's a very large number, so it does not recommit every time. It's only when you recommit that it does. So that's the max amount that U32 can get to, right? Yeah, so that's what is happening with delegate. So when we delegate the account now this time, The next thing now, when you want to update the account is no longer owned by Solana. It is now owned by the ephemeral roll-up, right? So this account too, you have to specify that this account that is signing. Let's go to update commit. Let's check it side by side. Update commit. So this is what's going on in your update commit. You are passing in a signer, the user, and the user account. So now the same user account, right? Then the signer. But the thing is, the user that we're getting here, we're getting the user, but we're getting the user with a different connection. The connection of the ephemeral roll-up. That's what we defined here. Defined, yeah. Because provider ephemeral roll-up is new anchor provider, but the connection is no longer DevNet. It is now Magicblock DevNet. You get that's just basically what we're doing there. So if you used your normal user account here, it will throw you error also because it's on the wrong connection, right? So transaction fee payer is also transaction fee payer is pub provider that will ephemeral roll up the wallet, the pub key, then you sign the transaction, send and confirm the transaction, then you log out you can now fetch. Okay, we're not fetching yet. We're just sending the transaction. User account state updated and the transaction hash of that transaction. I can check it on chain. So second one too. This one is commit. This one is update commit. So what we're doing here is just getting new data, whatever data you're passing to it, then just committing that data that you pass to the account that is on Magicblock. So you're committing it on chain. The next thing is okay. Let's do this way. Let me share. I want to do a quick challenge for Monday is a long time, right? And I said we should even have a number of people. Yes, I forgot. I guys not say anything. Number of people that will come up and show us what they worked on from Wednesday, only Wednesday. Yes, Wednesday till now Friday. But we forgot, right? And nobody said anything. Everybody was just like, cool, man. But now, I will not forget this time. You guys should come up with, even if it's the basic ephemeral roll-up example, spin it up. The test is, you can see it here now on, we come to this place. Not even the verifiable randomness now. The basic ephemeral roll-up before we get to the randomness. Counter example, delegate. You see, I think the example, if you go to Magicblock GitHub, you'll see it there. GitHub, Magicblock GitHub. Then repository, where's the main repository? Ephemeral rollup SPL. Magicblock validator, ephemeral rollup SDK. I think it's this one. Okay, this one is an SDK. Should it be the SDK? Let me check. Rust. So this is the SDK for writing it. I'm looking for the examples. In a minute, let me find out real quick. Yes, Magicblock engine examples. There you go. Aha. Anchor counter. This is what I want you to do. Yeah, Jonas made a contribution there. These are all I want you guys to do. To You can just manage to make this work. It's just counter example that can help you increment, and commit, delegate, undelegate. I think now you get an understanding of how it works, right? So you can still can do some back study on it to make sure you actually understand what's going on there, right? Then on Monday, you guys should do a show of what's called a show of GitHub repos. See who has done. There might be. I'm not saying anything, but who knows? There might be a price. Who knows? Well, nobody knows, right? So let's do this. and spin up the examples, and you walk us through next week, right? So yeah, so that is it for today. I don't want to keep us going long on and on and on and on. Let's just keep it here for today. The next week will be more complex stuff on Magic Block, right? Especially doing what I want to do. Magic Block. Magic Block has a super there's a super program example, right? What super program is your program which has uh an LLM still on top of it inside of the program. So you can interact with the program like via chat, like ChatGPT, right? So that's what I want us to do. You can do that next week. Be on next week on Monday stream or maybe Wednesday stream. You can see to get to that. Just how much more we can keep going at this, right? So yeah, that's it from me today. Thanks for coming up. Thanks for staying to now. And that is the Anchor founder. See you guys on Monday. Peace. Don't forget, come to before that, come to remove this. Come to this repository. Let me see if I can share the example on GitHub. Sorry, it's GitHub on Twitter. I'll share it on Twitter now in the chat. So if you want to code along, um, yes, drop the second one now. So the second GitHub is here on X. So let me share this too. You can see this now. This was the first one I dropped. Then this is the second one. Yes. So you have the two repositories here that you can go over. And let's meet on Monday, right? So thank you guys for staying and peace out.